Hey guys, it's Bill from Linden, Tennessee. Well, in a typical case of I'm just going to do something real quick here, ended up snowballing into a much larger project. All I was going to do is just replace these front drive shafts, um, but that ended up being a basically front end rebuild. The lower ball joint there, the bearings and seals on the inside of the hubs, the tie rods, and of course the drive shafts. These new drive shafts are kind of cool. The old ones, they had a slip joint in the middle and an actual like U joint on, I think it was on that end, and then just regular CV joint. But these ones have just traditional CV joints front and back, or inside and out. So that's kind of cool. I didn't replace the shocks because I don't think I'm going to really need them. I don't think I'm going to miss them being gone. I also replaced all the brakes and the wheel cylinders. On one of these wheel cylinders, somebody had put a bolt in place of the bleeder valve. It's like, I can't imagine how that would work. Well, I can, not very well. I need to epoxy these down a little bit better. Just these little debris guards, shields. And yeah, up front here, got a big old cavernous area where the radiator was. That's where the charger is going to go in the DC-DC converter. And moving our way back here, I've also started working on the wiring while I was waiting on bearings and such. I got the shop manual for these mules and the wiring diagram. And if you didn't know, this little device right here, this is your fuel pump relay. And the way they do this is really, really clever. Now, a normal relay, if you're familiar with it, it's got a little coil in there, and then it's got a set of contacts. And when the coil's energized, the contacts get pulled down, and it either opens a circuit or completes one. Well, this is a solid state relay. And the way they do this is ignition power is fed to it, and of course ground. But then the trigger for it is the one of the coils on the engine. And of course that's just on, off, on, off, on, off, on, off, depending on the engine RPM. So what happens is this thing at really low RPMs is, say, cycling on and off, well, if it's going 800 RPM, that'd be 400 times a second, 400 times a minute. Because they probably batch fire. Maybe they don't. And if they don't batch fire, then that's still 400 times a minute. Anyway, half the speed of the RPM. So this is cycling on and off 400 times a minute, and it's giving a pulse to the fuel pump. But then as you speed up, those pulses increase. You get up to 3,000 RPM. Now you're feeding this thing 1,500 pulses a minute. And it's making the fuel pump go faster, of course, delivering you more fuel pressure, and keeping your engine from starving of fuel. I thought that was really clever, the way they did that. I don't think I've ever seen another manufacturer do that. In fact, I'm really kind of impressed by how easy this thing is to work on. Man, it's just really, really nice. Everything's kind of accessible and easy to loosen and all that stuff. One thing I got to do is on the passenger side, there's 3 bolts that hold that flange onto the differential. One of those bolts was missing, and you got to take that flange off to get those axles out. You can whack at it all you want to with one of those tie rod end pullers or one of those CV joint pullers, and it won't go anywhere. You got to take those 3 little bolts off, and then it comes out like a champ. And what else? I don't know, back here, well, I don't have it right now. I'll probably cut to that here in a minute, but trying to figure out where my controller is going to go. Yeah, actually, let's cut to that. Yeah, that's better. Back inside, it's much cooler. It's 95 degrees out in the garage. It's not exactly humid here, but it's not exactly not humid. Anyway, inside, this is the layout for my high voltage junction box. And there's a few components that need to go in it. This is a fairly simple electric vehicle, so there's not a whole lot going on. A more complicated vehicle, inside of this, you'd have fuses for like an air conditioning system and a heater and all kinds of stuff, but this isn't really going to have any of that. But it does have a main fuse here. This is where power comes in from the most negative terminal of my battery. Goes through a 500 amp fuse, then comes over to this doohickey. This is called a shunt. This is a precision resistor, and whenever you run voltage across a resistance, you end up with a voltage drop. And there's another little gauge that I have that will record that voltage drop, and it'll count how many amps are going through this thing. And, you know, so many amps over so many hours is amps hours. And then that tells me how much energy I've got left in the battery. Then over here is a little junction block. And then that completes the negative side. Then this will go over to the controller, that silver doohickey that was on the motor. On this side, we've got the most positive lead coming in from the battery. That's going to go to this main contactor. This main contactor will be controlled by the controller. When the controller sees a key on signal, it'll turn this contactor on, and it'll send battery positive out through this, and it'll go out to the controller. Then the controller will send the amount of power necessary to the motor, and down the road you go, or up the hill or through the woods or whatever you're doing. One thing that caught me kind of funny, on one of the Mule groups that I follow on Facebook, there was a question asked by one of the members that said, what is your favorite activity with your mule? And and the answer was like riding it, accessorizing it, or exploring it. And the funny thing is, I didn't realize that that was the Mule group, and I thought it was just somebody just asking what's your favorite thing to do with a mule. Anywho, but yeah, whatever your favorite thing to do with a mule is, that'll complete the circuit, and then you can go. This is the actual wiring diagram for my controller. We're not going to get into this too much yet. We'll get into it later, but I may have already covered it. This is the wiring diagram for the Mule. And from this, I'll figure out like where my lights are, because I'll have lights. I'll have brake lights and all that stuff. And I'll have power going to the, like I was showing you, I'm going to have the controller, I'm going to have the charger and the DC-DC converter. That's a DC-DC converter. I don't have the charger yet. But those will be up in the front where the radiator was. So I'll have 96 volts going up there to a little fuse, and then that power will get either it'll go from the charger to the battery, it'll go from the battery to the DC-DC, and then that'll change the voltage to 12, and then it'll keep the 12-volt battery charged. But inside this junction box, I think I'm going to get rid of one or maybe both of these terminal blocks, because I don't really need them. All I need out of here, my ins and outs, is I'll need the contactor plus and minus from the controller. I'll have a shunt going out, and then I'll have a 96 volts going out. And that 96 volts, like I said, goes to that charger, DC-DC, and then also that gauge that I was talking about that the shunt watches. I kind of originally thought that I was going to put this DC-DC converter on the bottom of the box, but I don't think I'm going to do that anymore, just because it'll make, if I ever have to get to that thing, if it's a part that fails, it's a $30 component. I don't expect it to last forever. But if it ever did fail, then I'd have to get underneath this box, and then on top of this box or somewhere, I'm going to have the controller, and that'll most likely be in the way of access. The only serviceable item in here is this fuse. However, I do need to fuse the positive or the negative. Well, the negative most likely, because the positive is a really short run going from here out. I'll fuse the negative going out of this box, and in that way the wire from this box up to the front of the vehicle will be protected. You don't want to have the fuse on the other side of it in case there's a short. If there is a short, then the circuit itself will overload, the fuse will pop, but the short will still exist between wherever the short was and then feeding back into here where the battery was. So you want this as close to where your battery source is as possible. So that's what's going to happen in there. And I got all that stuff on order now. But yeah, I think I don't really have anything else. Oh yeah, here's the box that I made. I already made the box. Get all this stuff out of here. I kind of looked on Amazon trying to find like a plastic box with a waterproof lid or something, but I just went ahead and made a box. This is 16 gauge here, just 1/16 of an inch thick, and then this bottom piece is 11 gauge. That's 1/8 inch thick. And the reason for that is that I can take these and just tap. I can drill and tap straight into the bottom of that box and have mounting locations for all those components. So that's what I did that. And then I'll just make a lid, probably have little lips that fold down the sides of it, and then screw it down just to keep it waterproof. Put a little foam or rubber seal or something like that in there. But yep, that's going to take care of it. What am I doing tomorrow? I guess tomorrow I'll finish up the front end. I'll get the tires back on, and then I guess move to the back. I don't think that the rear drive shafts need replaced. I don't think they're in any danger. The brake kit that I bought just came with, of 4 sets of brakes and, 4 new wheel cylinders. So I'll just go ahead and replace all that as a matter of course, just because I'm there. But I suspect that the bearings in the hubs on the rear suspension are going to be bad, so I'll have to replace those, and of course all the seals and everything else. But yeah, I think I'll tackle that tomorrow, and then while I'm waiting for those parts to order, I'll go ahead and finish working with this wiring diagram. All right, guys. Well, until the next update, thanks for watching. We'll see you next time.